possible rational zeros test. Now, it should say possible, but this one just says rational. I just want to put this on for you guys. It's a formal definition of the rational zeros test, but let's get busy with an example. All right, so in order to factor this, you might come to this, you might go, oh, it's 4 terms. That means I can use grouping. And you start using grouping, and you're all excited about your decision to do grouping because you think that you're so awesome. And you're like, okay, so I take out x squared, and you get 2x plus 3. And then over here, you take out just a 1, so it says, or a negative 1 because it's a negative 8. So you take out a negative 1, you get an 8x minus 3. Then you go, oh, junk face. Look at this. The two factors are not the same, so that means you cannot use grouping, and so now you're sad. It has a degree of 3, and you have to factor this, and so what we have to do is we have to list out the possible rational zeros. Now, what is the difference between a rational zero and an irrational zero? How come all of a sudden it's saying rational zeros? So here is a rational number, 2 over 3. That's rational. A 4 is a rational number. Pretty much anything that you can write as a fraction is a rational number. An irrational number would be something like square root of 2. That's irrational because a decimal goes on and on forever. It never repeats. The square root of 4. This one, is it rational or irrational? Rational. This is rational because it simplifies down to 2, so it's rational. This is the only irrational number that you guys see up here. A couple more examples. Here is a pi. That is irrational. Here is a number. It's 2.666667. Or it's just like repeated 6. Or you normally round it to 7. Okay, if it just keeps going, it keeps repeating itself, that can be written as a fraction. This can be written as 2 2/3. That means that this is rational or irrational? Rational. That's a rational number. Okay, so these are the only 2 irrationals that are up here. So anyways, this is a rational zeros test. So we're looking for possible zeros, rational zeros. And so that's P over Q. If you guys saw that slide earlier, P represents the factors of the constant. Here's my constant. P represents the factors of that guy. And I love it that he's a 3 because that means there's barely any factors of him. Positive, a negative 1, positive, and negative 3. So there's only 4 numbers that would divide a 3. That is positive 1, negative 1, positive 3, and negative 3. And then we do the same thing for the bottom, which is Q. So this is where you get your Q numbers. Your Q numbers are factors of the leading coefficient, and that's plus or minus 1 and plus or minus 2. All right, so what does that mean? Now, this is an easy way to write all the possible rational zeros. I'm going to write all the possible rational zeros right now because it's actually not that bad. We have a positive 1 divided by a positive 1, which would give me a positive 1. We have a negative 1 divided by a positive 1. That would give me a negative 1. Positive 1 divided by negative 1 is still a negative 1, and then a negative 1 divided by negative 1 is a positive 1. So I don't have to write any more from those guys. Now, I could take the 1, and I could divide it by positive 2. Ooh, that'd be a 1/2. And then 1 divided by negative 2, that would be a negative 1/2. All right, and then we have a 3 divided by 1, a negative 3 divided by 1, so that's going to be a 3 and a negative 3. We also have a 3 divided by 2 and a negative 3 divided by 2. Ooh, so we get 3 over 2 and then negative 3 over 2. So these are all possible rational zeros. Now, normally when I start testing, we're using synthetic division. Normally when I start testing, I just start right here. But since I've done this problem before, I know that this will give me a remainder of 0. So I'm going to pretend I don't know, and I'm going to try negative 1 first. So I'm going to plug in negative 1. Oops, that's not a negative 1. Negative 1, and then I'm going to do my synthetic division. I have 2, 3, 8, 3. Do I have any missing terms there? No, I don't. It goes x to the third, x squared, x, then constant, so we're good. All right, so I bring down the 2. I get negative 2. I add those together, I get 1. I go 1 times negative 1 is negative 1. Negative 1 plus 8 is 7. 7 times negative 1 is negative 7. Okay, I did not get a 0. Okay, that means negative 1 is not one of the zeros. Like I said, possible rational zeros. Just because you find them doesn't mean it is a 0. Then you would just, since that one didn't work, you would just keep trying. No, I would not try the fractions right away. Actually, those would be the last things that I try. Let's go ahead and try 1. So I do 1, I go 2, 3, 8, 3. That 3 and the 8 is kind of a little too close together, but anyways, 2. Then we put a 2 right here. We add those, we get 5. 5 times 1 is 5. 5 plus 8 is... Did I write something wrong? Oh, it's supposed to be a negative 8. Huh. See, look at me making mistakes. Oh, it's supposed to be a negative 8 right here. Oh, you guys didn't catch my mistake there either? Oh my goodness, you guys are bad students. I mean, how dare you? Okay, this is negative 9. That'd be positive 9. That'd be good. What'd you say?
Oh, Megan.
What'd you say? Jerk face. All right, negative 3.
Oh my gosh.
What is going on? This classroom is falling apart. Oh, stop it. I'm not going to talk about your Care Bear belly power. Care Bear belly power. So look, we got 0 for my remainder. That means this is a 0. That's a 0. So if that's a 0, what's the factor that the 1 would come from? What's the factor that the 1 would come from if 1 is a 0? X minus 1. That's right. So x minus 1 times what? It would be negative 3, 5x, 2x squared. Okay, and that's a positive 5, right? Yeah, it's a positive 5. Okay, so I got 2, 5, and negative 3 right here. Okay, so this factor times this factor, that'll get me back to where I started. All right, what I did was I took this and I took out the factor x minus 1 by doing synthetic division with positive 1. Now I look at this and I go, okay, can I factor this without synthetic division, or do I have to keep testing numbers? Hopefully I can factor it without synthetic division. Okay, so this is one way to organize it. I like doing the big X thing. So 2 times negative 3 will be negative 6, and then I have a positive 5 I put on the bottom. So what two numbers multiply to give me negative 6, but then add to give me 5?
2 and 3.
Wait, what'd you say?
Negative 2 and negative, or...
No, be negative 1 and positive 6, right? That would multiply to give me negative 6 and then add to give me positive 5. And so I'm going to take this negative 5 or 5x and I'm going to split it up with negative 1x and 6x. Okay, so let's rewrite it. We got 2x squared minus 1x plus 6x. The order doesn't matter. And then we have plus 3. I'm going to group these. And hope that it works. I take out an x. If I factor an x out of this, what is 2x squared divided by x? That is 2x. What is negative 1x divided by x? That is negative 1. What can I take out of both of those? 3. So I take out a positive 3. What am I left with when I take out a positive 3? What is 6x divided by 3? No, it is 2x. 4. 3 divided by 3 is 1. And so now I can take out an x. Oops. What happened here? Where did I make a mistake? Oh, that's supposed to be negative. My goodness, what's going on here? Phew. Now we're safe though, because I was worried that it didn't work. All right, so I could take out a 2x minus 1, and I'm left with x plus 3. Hey, what was my other factor that I had way up there? X minus 1. So here it is, factored all the way. Let's do my cute little box here for my answer. That is factored. Oh, that's factored, but I got to find the zeros. What are my zeros? 1, 1/2, and negative 3. And look, all these are actually in here too. We could have picked other numbers and it would have worked.